So one of the big questions to the decorator is whether decorators are composable, whether you can have a decorator on a particular class. So let's take a look at how this is done. Now, there are actually two ways of doing it. There is the dynamic way and there is the static way. The static way isn't so great in the .NET framework. It's great in other languages like C++. In the .NET framework, not so good. So we're going to start with the dynamic decorator. Now, I'm going to show you a very simple example. Now, let's suppose that I have some sort of interface for defining a geometric shape. Let's call it I shape. There we go. So this shape might have a string representation that we want to print. Now, I'm not going to call it toString. I'll call it as string so that we get to see a difference between, what's inherited from objects. So we'll have as string as a method which is supposed to return a string. Now, I'm going to have a bunch of classes. So, for example, I have a circle, and a circle might have a radius. So we'll have a radius here. And then, of course, we can initialize this. So C_F will initialize this correctly for us. And then we can maybe resize the circle. So resize, and we'll have some sort of factor of resizing. And then we just say radius multiply equals factor, something like this. And then, of course, we implement the iShape interface. So here we have the iShape interface, and we can implement the missing members. And here in the as string, we may as well return something like, let's say, a circle with radius, and then write the radius. There we go. And let's reformat this to not to verbatim interpolation. I want to use an expression body. That looks nicer. Okay, so now we might also have a square, for example. So a class called square, which has the implementation of iShape, of course. So it has that as string, and we'll have the size of the side here. So I'll call this side, and once again, I'll initialize it in the constructor. Sorry, this should be C_F like so. And then, of course, when it comes to printing, I would just say that we have a square with side and specify the side here. Once again, I want this as an expression body. Okay, so we have the circle and the square. They have both shapes, and now we want to maybe color them. Well, actually, before we do that, let's actually show you the output. So we're going to start using maybe var square equals new square. Let's have its size, let's say 1.23f, and then I will write line square dot as string. There we go. So first of all, we'll take a look at this actually operating. So a square with side 1.23. Okay, that's good. Now we're going to have colored squares, and we're going to have squares with transparency. And we also want the circles to be colored or with transparency. So what we end up building once again is we end up building a decorator. And I have to stress that this is what's called a dynamic decorator, in the sense that you can make these decorators at runtime rather than compile time. So let me show you how you would typically implement this. So you would say something like, oh, I'm going to have a class called colored shape. Now, colored shape is obviously going to be an iShape. It's going to implement the interface, and it will have that as a string. Now, what colored shape is going to do is it's going to refer to some shape. So that would be shape like so, with the I in front, since it's an interface. We'll change that in a moment, and it will also have a color. Okay, so the idea is we now do a initializing constructor once again, which initializes both the shape as well as the color. Let me get rid of these, since we now have C#7. So I'll join both of those together. So now as string can be customized to display not just the shape, but also the color of the shape as well. So here we can say, for example, that I have a shape as string has the color, and then specify the actual color. And once again, I'll turn this into an expression body to look nicer. So this is a colored shape. This is a decorator that we can now attach onto the object. So for example, if I sort of go down here, what I can do is I can make a red square. Var red square equals new colored shape. And notice in the constructor it takes a shape, so I can feed it the square we have already and specify the color as red. And now, of course, I can write line, and I can write line red square dot as string, and we can see what the end result is. So here we have a square with side 1.23, and it has the color red as well. So this decorator is working just fine. Now we can make another decorator just to show the composition of decorators. So we're going to have a kind of transparent shape where you can specify the transparency. So for example, we're going to have a class called transparent shape. It's also going to be an eye shape, obviously, so we have to implement this interface. But in addition, we're going to have transparency as a float value. So we'll have the shape that we're decorating. Here is the actual shape with the eye in front, and we'll have some sort of transparency value. We'll make a constructor which actually initializes all of them. Once again, I'll use the join check null and assignment thing, and then of course we'll implement as string. So let's go down here, and here I'm going to return, let's have first of all the shape as string. So that's the description of the shape, has transparency, and we may as well put it in percentage points. So we'll calculate transparency multiplied by 100.0, and we'll say it in percentages. Okay, so once again, I'll turn this into an expression body, hopefully. There we go. And now that we have this, let's try using it. So we have a red square. We may as well now make a kind of half transparent red square. So I'm going to say var red half transparent square equals new transparent shape. So now we're going to apply the transparent shape decorator to a red square. To a red square with transparency 0.5, and we can this has to be float, by the way, and we can right line the result. So red half transparent square dot as string, and let's see what we actually get. So as you can see, we're now getting a square with side 1.23, which has the color red and has 50% transparency. So we are applying decorators on top of one another. Now the only thing that I want to note is that nothing prevents you from applying the same decorator twice, which means you can have a colored shape of a colored shape, which doesn't make much sense unless we're talking about mixing colors, for example. But generally, this isn't something that you can prevent. You can't prevent making a decorator from your own already existing type, unless of course inside this whole decorator chain you keep a list of all the types that have been decorated, and certainly this is possible. You can make a list of types and make sure that there are no repetitions in them, but generally this approach works. And the great thing about this is that it works at runtime. So at runtime you can make a new shape decorated with like colored shape or transparent shape, and everything works fine.